Hi, so this is the introduction to how to develop with the Pynq Z2 board together with the software Vivado and SDK. And the book we're going to use is the Zynq book and also the Zynq book tutorials together with the free provided code. You can find the link of the Zynq book and also the Zynq book tutorials and also the source code in the comment section. And also the code that I modified for demonstration. Everything, you can find everything in the comment section. Please check it out. But now let's go to some introduction before we go into our steps of designing the task. So our task is to control the LED, make those 4 LEDs. As you could see, these are the 4 buttons, but on top of the 4 buttons are the 4 LEDs. And our task is to make those 4 LEDs blinking. And even though that you can see the board has a lot of things, however, the area that we're going to design is only this Zynq chip, the very small square black area here, the Zynq chip. You can even see the name of this black area. This is the Zynq chip, and the board is the everything besides the chip on this very Pynq board, and the name is Pynq Z2 board. And our task is to design this chip in order to command those 4 LEDs blinking. And this is like the hardware design in our Zynq chip. If you see in the introduction, you will see that this Zynq chip will have 2 areas. The first area is the processing system area, and the next area is the programmable logic area. Usually, we only import this design into our design. We don't touch that much. We can configure some parameters, but we don't design anything else besides the thing already set up in the processing system hardware. The area where we can design for our hardware is the Zynq programming logic. And in order to control the LEDs, as you can see in this design schematic, they will create an instance Xi inside our programmable logic, and that instance will be the representative of those 4 LEDs. Those LEDs are these 4 LEDs. Those LEDs here are the 4 LEDs on the board. But the Zynq programming logic and the Zynq processing system block here, both of them belonging to this small black area Zynq chip. So in this small black area Zynq chip, we have to design a Xi block, which are the representative of our 4 LEDs, and through that Xi we can demand the LED to blink. So that's the task. Now let's go to some real actions. And before going to the work, I want to have some summary. So the summary, the first thing that we're going to do is doing the hardware design for our chip according to this schematic. Doing the hardware design for our chip according to this Zynq hardware design specified. And after we have the hardware design, we can do the software implementation. The software implementation is implemented in the Zynq processing system. So the hardware will be like we create the body, and when we do the software, we put the brain inside the body itself. And let's start. First is the hardware design in our Zynq chip to implement the software. So in order to design the Zynq chip, we use Vivado. The Zynq chip hardware, we use Vivado. I'm opening the Vivado, so let's wait until it starts. Okay, so I think you could see this is my Vivado, And now my board is not connected to my computer. I opened too much windows. Again, my board at this moment is not connected to my computer. As you can see on the board, there's no live signal, there's no LED indication that the board is connected to my computer's on. So I want to demonstrate that when you do the hardware design, you don't need to connect your board to the computer. The hardware design can totally independent of the board itself. Now let's create a project. Go to File and you create a project, New. And you go Next and you can name your project. I can name it like Intro Exercise. Let's say Intro 1. And I can choose the area that I will put my project. I will choose this like maybe in here, and I will create a new folder. I cannot create a new folder there, so I just have to go inside, open this one, and create a new folder. Intro 1. Okay, now I'm going back to Vivado and I will find the new folder that I made, Intro 1. Maybe it's not updated, so let's click cancel and click on it one more time. Intro 1 is here, so you can choose this folder, select, and you can create a project subdirectory. So when you click on create project subdirectory, you will see your project will be stored in this subdirectory, Intro 1. You can name it in another name, let's say like Intro. Introduction, let's say. So it's more clear. This is the Intro 1 folder that we created in our C, but when we click on project subdirectory, there will be another subdirectory, Introduction, where it contains our project. If I uncheck it, the subdirectory disappears. But I prefer to have a subdirectory for my project, so maybe inside the same Intro 1 I can have many projects. Click Next, and I want to have the RTL project. I have no source file, as I need to specify that the target language is Verilog and the simulator language is mixed. Mixed is mixed between Verilog and VHDL. And I click Next. Constraints file .xdc is the file specifying the pins, the pin configuration on our board, and for the new version we don't need that, so we can just click Next, and now we need to file our board. Pynq Z2, click Next, and everything is done, finished. Okay, now you are in a new window perspective. I will just close it. Okay, new window perspective. And my board is not connected to my computer, still not connected to my computer. The first thing we need to do is we need to create a block design. Block design means the hardware design for our chip. So of course we have nothing. We click on block design and we can name our design. Let's say Introduction Hardware Design. And the directory is local to our project. I like that. and this file name will be underneath the design sources folder. As you can see, this is the design sources folder. Our file will be inside this folder when the process is completed. Now we are in the design tab. If you click on the sources tab, you could see our file introduction hardware design now is inside the design sources folder. And of course we want to design our hardware, and according to this book we need to have the Zynq processing system and also the XI specified in our Zynq chip. So we go to the design tab, we choose on the file, double click, and it will lead us to the window diagram where you can design your hardware. So first we need to add the Zynq processing system. In order to do so, you can click on this plus button, add IP intellectual property, or you can click it here. They even have some hint like you can control plus I. But let's just press whatever among those three methods. And now we need to search for the Zynq. What we need to search for is the Zynq processing system. So we type Zynq processing system, and here double click to choose the block to add in our diagram. Okay, it's done. Now we have the run block automation. This run block automation will automatically configure our processing system Zynq for the first use, but we will do it later. Let's add all of the blocks required in our design before we do anything further. And the next is we need to add the XI. We go here, click on the add IP, and we type XI GPIO. Okay, you can click on this maximize symbol to have the schematic big. The processing system Zynq represents the PS domain of our Zynq chip, and the XI GPIO here, you can click and zoom it. The XI GPIO is another IP block that we create in the programmable logic area of the Zynq chip, and this XI GPIO block will represent the LED, and through this XI GPIO we can control the LED, and also the LED can send back we can even read the signal from the LED through the XI GPIO and process in the processing system. And before we run the connection automation, we better specify all of the properties if necessary in those blocks before we run the connection automation. So we want to have the XI GPIO connect to the LEDs. So we choose this XI GPIO block, double click on it, and here we can see the recustomized IP window open in order for us to configure to customize our XI GPIO. And as you can see, there are two interfaces. In other words, there are two channels, two ports, and we just need to use one port to connect to our LEDs. Board interface, and IP interface. So what does it mean? So IP interface is the interface from our Zynq chip, and the board interface is the interface from the peripheral devices on the Pynq board. And we want to connect the interface of the XI GPIO to the interface of the LEDs. So that's why on the board interface we choose LEDs 4 bits. LED 4 bits mean each bit represents a LED in this interface. We have 4 LEDs, so we need 4 bits to represent 4 LEDs. And that's it. We click OK. Now we can run the connection automation because we already configured this block should be connected to the LEDs on the board, so the run connection automation will automatically connect our XRTVO block to the LEDs that we already configured. And if there are some necessary like additional auxiliary blocks between the processing system and the XRTVO, this run connection automation will help us out. Now let's run and we will see the results. We will choose for all of the connection. For the XRTVO, we choose 4 LED bits for the board interface, yes. And the XRTVO block have 2 interfaces. The first interface is the GPIO, where it is connected to the board peripherals devices, like the LED in this case. And the other interface is the XI interface. The XI interface, in this case, is the communication between the XRTVO in the programmable logic domain with our processing system, Zynq. And this the XI connection is the connection between our XRTVO with the processing system, Zynq. This one we choose as default. We click OK and we wait. Now everything is set up automatically for us. Now we need to run the block automation. And when we run the block automation, you can see which block under the influence of this run block automation, which is the processing system 70. So the run block automation will do some initial configuration for our Zynq PS, the processing system domain. We click OK and we wait. Okay, if you can see those blocks here, these are the domain inside our Zynq chip. Okay, again, when you look on the board, this Zynq chip physical area is represented by this domain. The domain where it contains only the blue blocks where you can click and double click to configure the properties of the block. But the gray arrow pointing outside indicates the connection between the Zynq chip area to another devices outside the chip. So for example, this gray arrow leads to the connection of the 4 LEDs outside our chip. So I just want to introduce that's it. And this is done for hardware design diagram. We can validate our design by click on this symbol and the validation is successfully. That's a good news, so we can click OK. And now we go to the sources tab. We choose our introduction hardware design file. Right click to generate the HDL wrapper. So again, after you've done the diagram design for our hardware design in the Zynq chip, we need to generate the HDL wrapper, which will be very important for implementing the hardware on the chip. So we choose the option of let Vivado manage wrapper and auto update. Choose OK and we wait. It's still running, updating. Now the process of HDL wrapper generation is done. After the HDL wrapper is done, we need to generate the bitstream for the whole design and the wrapper. So as you can see in the flow navigator area, we scroll down and we choose generate bitstream. There will be information about we have no implementation results available. So when we click on generate bitstream, when we don't have any implementation results, what the software will do, it will launch the synthesis part, and then it will launch the implementation part. When both of them are done, the synthesis and the implementation of our design here are done. the bitstream generation will start automatically, and that's what we like. So we click yes. We can choose like maximum number of jobs. I have only 4. If you have more, just choose maximum and runs on localhost my computer. So I click OK. And now we wait for the generating bitstream. It has been finished. And we wait for this process to be finished. And this step takes a lot of time, so just be patient. And until this moment, my board is not connected. Again, until this moment, my board is not connected to my computer. So my hardware design step is totally isolated from my board. It's only necessary to use the Vivado software to design our hardware design for our chip. Even though that you see nothing, but it's still running. Here, when you look at the upper right corner, there will be a circle running, indicating that the generating bitstream is in process. We need to wait until the running circle turn to a green tick symbol. And now I will stop and wait until the generating bitstream step is done.